Hello, 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 and welcome to a very special Wrench Army exclusive edition of Gearhead Diva, because today we're going to do something very different than I've done before, in that we're going to do something for the goodness of mankind. Not just for me, for you, but all of mankind. I'm Rachel DeBarros, and today we're going to be trying to prototype a flatuosity meter. And of course, that's fancy for FART-O-meter. That's basically what we're building. So if you are squeamish about the behind area, or you're squeamish about butt jokes, fart jokes, this is probably not the stream for you. But if you're like me and you just can't stop giggling like a little kid anytime everyone tells any one of those jokes, then join, because we're gonna have a lot of fun. Now, of course, for this stream, we're gonna ask Madame Curie to step aside, Elon Musk, Benjamin Franklin, because what we're gonna do is way more important. We are going to try and answer that age-old question that has been plaguing mankind, which is he who dealt it really smelt it, you know? And or he who smelt it really dealt it, or he who denied it supplied it. There's so many of those. I can go on and on, but I'm gonna try and limit the time, or else, you know, we're not gonna get to this for another hour, you know, for all my fart joke telling. All right, so for this project, I mean, how do you even go about making a fart meter? And I already see some questions coming on board, like, what the heck is this? I'm glad you joined, because I think this is going to be a whole heck of a lot of fun. So, in order to build a fart meter, the first question I had to ask myself is, how are we even going to measure this fart? Are we going to measure, like, velocity? Oh, do you guys hear that? I think I have a little buddy joining the stream. Let me look at what's going on here. Wait, there's something under the table, completely interrupting us. He loves electronics. This one right here. Now, this is Amicus Arcane, and via coincidence, look at my shirt. A ghost will follow you home. And this is from the Haunted Mansion ride. We named him after the Haunted Mansion librarian, Amicus Arcane, and his sister is Madame Leota. So, enough of that. He loves to help with electronics projects because of all these small little parts right here. And so, I want to watch you, because you run off with things, and then I'm like, where are my LEDs? So I'm gonna put you back down here. So if you hear any noises, it's probably him. Anyways, how do we detect a fart? I don't know. So I started to do some research on the best way to do this. Like, do we calculate it by wind versus like the wind that's going on in the area? Or perhaps we do it by smell. Like, what kind of smells should we look for? There's so many sensors that we can use. Here we go. He's already going for it. So, according to my research, oh, and look, the camera likes him. Look how the camera's focusing on him, and I'm just like, oh, you know, she's not important. She's just like, meh, 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 about farts. So, let's move you back over here. All right, now we both can have the spotlight. So, got some fun fart factoids for you guys. And number one, I didn't know this, but over 99% of a person's fart is odorless. Like, you can't even smell it. You would think with some of the stuff that like we've all smelled that it would be like the majority. So over 99% totally odorless. And the gases that make up that 99 odorless percent are things like oxygen, nitrogen, carbon dioxide, hydrogen, and methane. So of course, hydrogen and methane being the flammable ones, you know. That's where the silent but deadly comes from, you know. Silent, can't smell it, but dang, kaboom, if you're not careful. So that means that the remaining 1% is the stuff that you can actually smell. And it's thought that these come from either ammonia, but most people believe that they come from sulfur compounds. So this starts to kind of like hone in on things that we can target to measure a fart. So other fun factoids, a human's fart 8 to 20 times per day. And in that process, we expel 476 to 1,491 milliliters every 24 hours. That's like filling halfway a 2-liter bottle every day. Yikes. And farts also travel pretty fast. They travel at 7 miles an hour. So you may not be able to outwalk a fart, you know, when you're trying to be all sly and just kind of walk away when you smelt it, which means you may or may not have dealt it. But you can certainly run away from a fart. Yeah, you can run faster than 7 miles an hour. But if you're on one of those like hoverboards, I don't think they go 7 miles an hour. So you are out of luck. Just carry that thing and take off running. So now we know the composition of gases, and this started to kind of narrow in on perhaps a sensor that we can use. And I picked up these two sensors right here, and I'll give you guys a closer look of how this works. And my two sensors are these. And you know what? Let me just kind of give you guys a much better view of what's going on here. Isn't that better? Yeah. All right. So it also helps if we're in camera here. One of these sensors, if you read the side here, says MQ4. And this sensor right here, let's see here, says MQ135. So this sensor is great at detecting methane. Like we talked about, over 99% of your fart doesn't smell, and a component of it is methane. So this is probably a good one. The only thing is that, like, I started thinking, well, what if you don't release all that much methane, but you sure have a lot of sulfides? Well then, you know, a really stinky fart, this would measure it as not that bad. So there's a couple flaws maybe in using this methane sensor, but I decided to pick one up anyways and perhaps run a side-by-side test. The next one is the MQ135. Now, I pulled up the data sheet on that sensor, and it can detect anything from, it's basically an air quality sensor. So when the air quality goes down, it can alert you and you can monitor it. So it'll look for things like ammonia, nitrous oxides or nitrogen oxides, alcohol, benzene, smoke, CO2, and other natural gases. So these are all things that come out. So I imagine that we can use this and it'll know, okay, well, this is what's normal in the area. And when any of these gases elevate, then it can alert you like, hey, danger, there's something going on here. But a couple different data sheets will say that it also responds to sulfides. So we can definitely find out if that's true. Now, there are dedicated sensors to sense all kinds of things. If you only want to sense smoke or carbon dioxide or only sulfides, and they range in expense. So these guys are wonderful because they're like, you know, less than $10. And I always like to buy a 2-pack or more because sometimes it does come damaged from the factory or it doesn't work, and you always have a backup just in case. So these are going to be our fart detection little devices right here. And so somehow we need to take the information from these and kind of get it into something that we can read and we can measure. So I decided to do this with Arduino, and I picked up a little Arduino board right here. And this is a fun project. I've only started recently working with Arduino. It's relatively easy to learn. So we'll kind of go through everything and you know, kind of get the basics down. And for some of you who are very used to working with Arduino, some of this may be review. But if this is your first time, I think, you know, you're going to get a nice foundation so you can take off and build your own fartometers or, you know, build other projects. So of course, this is a live prototyping. So feel free to post your comments, suggestions, and reaction moments in the chat because I'm looking at all that and I try and get to as many of your commentary as possible. So let's get started here and kind of look at what this Arduino board is. So nice little you know, close up here, and I'm gonna bring it into view for you guys. And Arduino is basically an open source platform. So that means that I can take this board and remanufacture something similar, it's open source, and sell my own version of it. So you'll see that there's Arduino boards, there's other, you know, copycat boards on the market, and you know, they all have their pluses and minuses. I myself started with the original true Arduino Uno board because a lot of the tutorials online use this very board, so I thought it would be easier to start that way and see where things are plugged in, and it would match exactly what is going on in the tutorial. So looking at this board, and the other half of Arduino is learning the code, and there's free software that you can download. It's called IDE, which is an independent development environment. I believe that That's what it stands for. It's very easy to learn. So if you've never programmed, they have examples ready to go so you can start your project. And looking at this board here, there's a lot of, little things going on, but, let's take a closer look. Here on this side, we have our power. So you can tell that's your typical barrel jack right there. And that's how you would power the Arduino, especially if you want it to be portable. You can hook it up, either plug it into the wall for non-portable or, plug it into another portable power source. I generally use the USB here. This is how you plug it into your computer and then download the code into the board. And you can also hook up power through here. I usually like to use those cell phone chargers. They last a decent amount of time, and they're also rated pretty safely for this board. So looking at some of the other little goodies on here, the first thing you can probably tell here is this microcontroller right here. And this is what receives and stores your code and executes your code. In our cases, this microcontroller, we're going to call it the Let Rip microchip. Now, I'd love to take credit for that, but man, as soon as I started posting about this project, you guys were hilarity. Just the hilarity ensued, and all the different things that you were, different sayings. Some of you dug up some really old who supplied it, denied it type of things, and the rhymes just went on and on. So our Let Rip microchip is right there. And then the other thing you'll see is this row right here of pins. And these are your digital pins here. They go from 0 to 13 that you can plug in. They can be used as inputs or outputs. So an input in our situation can read our little sensor here, or we can send it as an output that would then output voltage to LEDs like the ones I kind of have around here. So you can set it for either its default set to input, but you can tell it, which ones you want to use for outputs and inputs. Now, the other thing you're also going to see is some of this. Let me see if I can get in a little closer. Whoops, wrong way for you guys. And let me move this into view. And the other one you'll notice is right here. I believe I'm trying to read upside down, but ground. You'll see a couple different areas where you can ground your circuit, and you can use either one of them. No one is more special than the other. But then let me turn this around on this side. You'll see, I'm just kind of looking for myself so I can point to you guys right there. You'll see 5 volt and right next to it 3.3 volts. These are used to power your circuit. So you would stick, your power in there, and of course ground for ground, and that's what sends out the power. So of course, being 5 volts, you're not going to power anything super crazy, but you can do a lot of fun and really useful things with this. Let's see, back, well, since we're over here, we might as well look at this strip right here where the power and the ground is. But if you look over here, you can see these are analog pins, which are different than these digital pins. This can read a range, which is great for things like potentiometers or sensors, because instead of reading like, oh, power on, power off, it can read a range. And this takes this analog value right here and converts it into a digital range from 0 to, I believe, 1023 or 1024. And so, of course, more or less wherever you fall in that range. So these are the ones that we're going to be using to supply or to receive a signal from our sensor right there. Other things going on this board right here. You might be able to hear the click. That's a reset button in case something goes haywire, or you just want to restart your code again and start the entire process. You can just hit that little reset button there and it'll reset the board. Let's see, there's a little LED indicator light right here that will tell you that the board is receiving power or not. So say you plug it into your computer or you plug it into a power source and that stays off. Well, something's going on, and you can start your troubleshooting right there. Here you can see the TX and RX. So that's for transmit and receive. You'll typically see those lighting up when you're transmitting your code to your board. So you see those little lights light up. And let's see, any other kind of like fun things going on here? Well, we're not going to use this for today, but along the digital pins here, you can see these little squiggly lines, these little tildes next to some of the inputs. And it's like, what the heck is that? That's for pulse width modulation. So and it also acts as a regular digital pin too. But with this extra feature, it allows you to, it kind of acts like an analog input. So say, for LEDs, you can turn it on or you can turn it off. But what if you wanted to fade an LED, a nice gradual, maybe kind of like candlelight type of fading and brightness? Well, then you can use one of those pulse width modulation pins and you can get that effect. But for our meter, we're not going to need that today. We're just going to use regular old digital pins and one of the analog pins to drive our sensor there. So I'll put this little board aside here and see some of the rest of the things that I have lying around. In order to prototype, of course, having breadboards is always help. You can definitely use PCB boards and solder, but if you make a mistake, then you have to desolder. These are just so much faster, simpler. You can rearrange components and find the best layout without having to go through all that hassle. So no soldering for today. That'll be a separate how to solder video. I have a box here of LEDs as well. So let me give you guys a closer look with these LEDs, and they come in two sizes. We have these bigger 5mm ones, nice little yellow, and we have tiny ones like this little guy. We're going to be using the nice big ones because listen, if something's afoot, little gas of a project going on, we want to know. So we want the bigger LEDs. I'm going to put that aside. And then the other thing you need that'll help you are simple, fast jumper wires. Now, these are really simple to be able to plug into your board in the Arduino. They come in all kinds of different sizes, as you can see here. Tiny ones and like really tiny ones over here. And man, I have to organize these. Look at this. Look at this hot mess of colors right here. But we'll be using some of those today, and I think that's about it. I do have some scattered little LEDs here. And so I have a red one, a blue one, and green and yellow. So at first thought, I'm thinking, green for its safe, I think. Blue maybe for its caution. I think something's going on. You still have time to run, so start that process. Yellow is when things are, pretty bad. You might reach that bad guy in Raiders of the Lost Ark, the Nazi bad guy, when he picks up the wrong chalice and his face melts off. Maybe that might be yellow for those toxic gases. And red, we have to reserve red for just the most awful Chernobyl, nuclear, military grade type of stuff. These people should be carrying permits. They really should. Can't just unleash that on the human population without any kind of warning. So we'll be able to check their paperwork and see if they comply. All right, and since we are using LEDs, well, we got to use some resistors too. Now for resistors and LEDs, a 470 ohm will do for just about any LED project. I'm using 220 ohms, and for any LED, you can look up their specs and find out exactly which resistor to use. If you use a resistor that's too high, well, that's not really a problem. It just means that your LED will glow a little dimmer. So if you want to maximize that brightness and find kind of what that maximum range is, there's online calculators. You could do it by hand. I usually just like using the online calculators. So for this instance, 220 ohms is more than enough. And it looks like this, just to kind of give you an idea. And most of these electronic projects involve LEDs, so it's so inexpensive to buy just a pack of 100. That way if any of them are bad, I've never really had a problem with LED or resistors being bad in a pack. Usually it's things like little sensors that, it might be a little faulty from the factory. So I like to buy in multiple packs for that. All right, so let's get started on kind of like figuring out how to hook all this stuff together. So I think we should probably start with the sensor because that's kind of like, the holy grail of this entire project. And because we don't have a lot going on in terms of components, is basically the sensor and LEDs. I'm gonna pick my tiny breadboard right here. So let me take a look and find the best orientation. If it's going to be like this, like this, like this, you know, maybe I'll kind of hook them up like that. And let me give you guys a closer look. I'm coming in. All right. And I am just going to get these kind of positions so you guys can see them. It's like backwards for me. All right. So I'm just going to back up. Whoop, wrong way. Back up just a little bit. And there we go. It's a perfection, or not. It's just getting all crooked now, isn't it? Oh, there we go. It's like the opposite of what you think. All right. So board and breadboard. So the first thing we want to do is connect the board to your breadboard, so that way the Arduino can power your breadboard, right? So you'll see a red line and a blue line, so for power and ground. So the first thing I'm going to do is I'm going to, whoop, my little friend is knocking stuff over. I'm going to get up off my chair and kind of take a closer look, and hopefully my head won't get in the way here, because I need to find that 5-volt power. And let me grab another one of these. And I'm going to use red, you know, for power. It's kind of like standard. Honestly, you can use any color that you want, but I'm just going to stick with what I usually go with. And I'm going to find the 5-volt pin here, which is, let me see if I can see in this glare, this one right here. So I'm going to poke this little guy in the 5-volt power, and I'm going to totally get my head in your way here for a sec. And I'm going to grab the board away just so I can take a closer look. You know, these mature eyes, very mature eyes, which is a good thing. There. So the board is back, and I believe I have successfully put that into the 5-volt. If you guys see it as another volt, let me know, but this is what my eyes see. And I'm going to route this little guy up and around, and I'm going to plug it right in here into the positive. So you can see there, whoops, if he wants to stay in, that would, you know, help us out a ton here. Or I'll just go next one since he's been temperamental. There we go. And I'm just going to bend this around so that way it's kind of out of the way. That's the nice thing with these jumper cables. They kind of bend up and out of the way. All right. So next we got our power hooked up. Let's hook up our ground. So we have all the basics, you know, out of the way. So for ground, I'm going to try and find a dark color here. You know, I have one lying around here. This is a dark gray that I have. I think that'll do for ground. Maybe we can use blue. Sometimes I use blue for ground, but let's see here. And there's a convenient ground pin right there. Right here, where we don't have to loop the loop so much the way I did. So I'm going to go ahead and use that ground pin and put that into ground. And see how these jumper cables make it so easy, like bam, it's like wired. We don't have to sit there soldering. And I'm going to loop this guy around and hook it to the ground of this board. So now the board is getting power and it's in the circuit. I mean, it's not getting power right this second because we don't have the board plugged in, but using our imagination, that is what's going on. So the board is hooked up, and now let's hook up our analog sensor. And to do that, let's take a very close look at the, oh, that's the MQ4. Let's take a close look at the MQ135. I think I'm going to start with this one. It reads a variety of different gases, so I think this will be pretty good for our purposes. So I'm going to flip it around, and the thing you mostly have to just worry about are these pins right here and figuring out which pin to hook what up to. So in this instance, I'm just going to, whoop, wrong way, zoom in as much as I can without it freaking out. All right, so if you look at these pins, and it is really, really tough to read, I'm doing this, but this is the VCC pin. So power would go to here. Here it says AO and DO. So of course, AO being your analog out and DO being your digital. So of course, we're going to use this little pin right here for our digital, for our analog out. And then ground, I believe, is this guy right here. So I'm going to take a closer look for me, so I make sure I tell you guys everything right. And I believe that's what it is. Of course, I didn't bring my glasses to the stream. It's always the thing. It's either always on my head or in my pocket or sometimes in the fridge, you know. So yes, the VCC pin is your power, and AO is the analog that we're going to be using. And then of course the ground is the ground. And we'll figure out if I read everything correctly as soon as we hook it up. So remembering that this is the power, you know, just so I get the orientation correct, I'm going to go ahead and put this into the board. And I'm just going to kind of, you know, maybe I'll kind of put him over here in this very last row. And I'm just going to gently push him down. So he is hooked up into the board, and I'm going to back us up just a little bit so you can see what I mean. I'm going to take this board and just flip it and see if I don't unhook it from the Arduino. There we go. So you can see that he is in the board. And if I were to just kind of pop him out and then pop him back in. There we go. So he's connected. And let me arrange all this back again. A couple things got unhooked. My ground is there. I'm just going to take this. There's a little protective cover here that you can use to screw your Arduino into your final project. We're not ready for the final project. Let's just, we're still prototyping here. So the grounds are still connected, and this came loose. Let's repower him up. Repower, that's my word. All right, and I'm just going to pop this guy off to make sure I have him in the right. You just have to try and follow the little rows. There we go. So he's hooked up. The board is getting power. The board is getting ground, but he still needs power, and we still have to connect his signal line. So from what I recall, the pin right next to the, I gotta take this out because I don't remember what they are. Ah, so AO is that one. All right, so we're good. It's just when you turn it backwards, then you gotta remember which is which. So the one on my left is the power. So let's go ahead and connect that up. And I'm gonna use this little red jumper. And again, all it means is connecting from this red bar to that pin. So I'm gonna do it here and then flip it around for you guys to see. So I'm gonna do that. And where the pin is, I'm gonna stick the other end. And from use, sometimes these jumpers their little ends do break off. So sometimes you gotta fish them out of the holes. So I think I'm going to connect it to the power first. And then there. So I'm going to just unhook. You know what? I'm going to unhook the power and the ground for now. Just kind of move this out of the way so we can see what's going on. So as you can see, I'm touching this red power bar here, and I'm hooking power to the very first pin, which I believe we said was the power pin. And I'm going to flip him around to double check that that is so. Yep. So the next one we're going to connect is this pin right here, which is our ground pin. And we're going to connect that to this blue bar that you see right there. So let's see, do I have a dark color to represent our ground? And I try and use the same color for all the grounds. That way one ground is in blue and then the other one's yellow. It's great for the day you build it, but then when you have to go back and figure out what you did, not so good. So I'm doing that here. And you know what? I'm just going to remove that because I know that the ground is right next . You need the hands of a 4-year-old to do this sometimes. That's why a lot of these electronic videos are done with pictures, you know, because the footage, you see the person all fumbling about, but no, we keep it real here. So what you can see is, let me move this little power guy over a little bit. And so so I can access the ground a little bit easier. There we go. Now everybody's happy. Mostly. All right, so what you can see here is that I have the power going into the power pin and the ground going to the ground pin. Now I can connect it to anything along this row because it just will act, these are buses. So you don't have to go right up to the pin or anything like that. This kind of helps keep things a little bit easier. And in fact, I can even use, I guess I just don't have the right size. Yes, if I had a small guy like this, I would connect the power in the similar fashion with the small guy so you don't get things snaking around. Now I'm going to skip this row because remember that's our digital there. And I'm going to continue with this row and plug our signal wire into this row. And then the other end is going to go into our analog out on the board. So let's pick a color for the signal wire and let's see here. You know what? Next weekend is Halloween, so what in this project is a little Halloween. So why don't we pick orange to celebrate? And I'm going to go ahead and skip this row right here, and I'm going to move on to this row, and I'm just going to put that in there, and then I'm going to put this back again, making sure that my power pin matches up with the red and ground and signal and all that goodness. So I'm going to flip the board to me so I can actually see what I'm doing and then flip it back to you guys. And there we go. And it kind of sits on top of the signal wire. So I'm going to move the signal wire one down. All right. And this will be our opportunity to test the board as well, just to make sure it's working. The parts are so small. All right, let me flip it to see what's going on here. So we have power to the board via this red wire, ground of the board via this wire. So you can see this red wire is connected to the red bar. The other wire, the ground wire, is connected along this blue bar right here. And then we have the signal coming out, which is our very last little pin, because remember this pin here was the digital and we are using the analog there. So that's coming out and it wants to reach for the analog of our Arduino board. So I'm going to sit that there and bring back the Arduino board. I'm just going to move these out of the way. We'll connect all this, the easy stuff later. So I'm going to move that into frame, and I'm going to go ahead and use A5 because that way the wire doesn't have to travel that much. It just kind of pops right in there. And again, I can select any one of these analogs right here to plug this into, and it really doesn't matter. This is, the first one, A0, A1, A2, all the way up to A5. So we're plugged into A5, and you want to remember where you're plugging things in because we're going to take where all this is plugged in and transfer it to the code. So it's nice to have your board in front of you so you can kind of reference what you did. So I'm just going to take this signal wire off and take one last look at this. I wish I had oh, awesome, new subscriber, Wenzi Zhang. Thanks for joining. That's awesome. Glad to see you here, and thanks for joining. You are in the middle of our FART-A-meter project. So if you're joining, we're kind of prototyping here. And yes, I believe I got everything right. So half the battle for me is just being able to see all the tiny, tiny little writing. So those of you with the more immature eyes, you may have an advantage here. So again, I'm going to position these guys back up and rehook our signal wire to the analog port there, or the analog pin. And what's going to happen is when this is powered up, that will allow the sensor to send information via this wire to the analog pin, which then gets converted into a value in our program, and then we can get that value and make it do stuff. So onward with the making it do stuff. Let's fire up some LEDs. Now, I thought it would be kind of neat when this fires up to have a way we know that it's on. Of course, you have your LED indicator light, but it'd be nice to have an LED that indicates nothing's going on. No one has like had, you know, beans for lunch or anything like that. The environment is safe. So this is our environment is safe LED that I'm using. Now, when you look at an LED to wire it up, and some of this may be review for a lot of you guys, and I'm going to move this out of the way, see if we can get a better view. You'll notice that one end is a little bit longer than the other end. So the long end is always your anode, and you want to hook that up to positive. And your short end is always your cathode, and you want to hook that up to ground. So on your board, you just, when you put it into the board, you want to remember which way you put it in. So I always come up with like a standard for myself. I always put the anode on the right when it goes into the board, so I remember. So bringing the board back, I'm going to go ahead and just kind of pop these LEDs, remembering that for me, for you guys it'll be on the left, but for me, the long end is on the right. So I'm just going to put, I'll put the little green guy right here, and you just push him in, and you can see that you want one leg to go in one bus lane and the other leg to go in the other bus lane. So you don't want them like together or sideways or anything, or along the same bus. You want to separate them out. And I'm just going to do the same. So green is for things are normal. Blue is going to be for, you know what, some starting to get a little suspect up in here. So I'm going to put the blue right next to the green like that. And again, this is just prototyping. We're going to come up with a final design and make this look really cool. But we just have to see if this idea is even going to work. I mean, this might be a total bust. Yellow and red. So I'm just going to make sure that I did indeed, because sometimes I get to talking to you guys and then stuff gets hooked up backwards. There we go. So the final product here is this. Well, not final, almost final. We have our sensor, and then we're going to use each of these LEDs to light up when it senses different ranges of the sensor right there. So let's hook up the LEDs to power and ground so they're all ready to go. And to do that, of course, you have to hook up resistors in series with the LED. So how do you do that? Well, because it's in series, you can put the resistor on the negative or positive side. It actually does not matter for this. And I know it's like, for me, I've always, my convention, I kind of follow the convention flow, which is that signal or electrical current flows from positive to negative. But a lot of us in school have learned it the other way. Well, not the other way. We learned more about electron flow, and electrons travel from negative to positive. So it's like, well, which is it? And it turns out they're pretty much both right, as long as you pick one convention and stick with it. So for my mind and the way I learned, I decided, you know what, I'm sticking with the conventional current view, which is it goes from positive to negative. So what I want to do is put the, for me, I'm going to put the resistor on the positive side. A lot of schematics you see down online, you're going to see them on the negative side. So don't freak out and think, oh, that's wrong, or what I'm doing is wrong. Although, you know, I do a lot of things wrong. But for this, it really doesn't matter which way it goes. So 1, 2, 3, 4. Since I have 4 LEDs, I figure I'll connect red, yellow, blue, and green. So green in there, and now of course I'm going to hook this up to the anode of the green, which is right here. Sometimes you just got to keep the lanes straight, so that's the toughest part. So that goes to our, and if I trace, that indeed goes to our anode there. And now we have to hook it up to ground. So let me take a look at what I want to use for ground. And I can use this little guy right here. And let's see if I can stick my hand and do it. You almost need like little pliers. You know what? I think I'm going to hook up all the grounds first and then put the resistors, because they're so much easier to hook up. So I'm going to go like this. There. So you can see that if I follow this end right here, it goes to the cathode of the LED. So we're going to do that 3 more times. Find the cathode and just hook it up to ground. Now, of course, on the ground side here, it doesn't matter which hole you pick along this line. The hole that's important are the ones that are leading to or following the buses to get to your individual components. So now I'm going to do the same with the yellow. And because by my own convention, this is not right, wrong, or indifferent, I always put the anode on my right. I know that the left leg is always ground for me. So that, and then, where's my other? Here's another little guy. These little guys are easy. Imagine having to solder all this together. We're pretty much a good ways into our prototyping, which is pretty cool. There we go. And let me just, I'm gonna flip this to me for a second so I can make sure that everything is hooked up right. All right, now we're gonna put in the resistors, which I started with and figured very quickly it was a bad idea. So from the anode, and what did I say? This is the fourth one over, so 1, 2, 3, 4. This is going to be pin number 10, right there. And we're going to do the same here. I'm going to hook it from the anode. Oh, come back, runaway resistor. The anode, and this will go into pin 11. Make sure everything is pushed down in there, so things don't go haywire. All right, or they just don't work. They don't really go haywire. Haywire sounded way more exciting. All right, and this one will go into pin 12. There. Get our little, everything looks kind of neat when they're in this. It's almost like you're a mad scientist making something kind of cool, which we are. We are. Step aside, Edison and Dr. Frankenstein. We're making our own, well, this is a Frankenstein project right here, that's for sure. All right, and I'm going to put this into pin number 13. So all of our LEDs are hooked up. And to review, we have our cathodes going to ground and the anode going to the resistor. So basically, in my current flow convention, the current would come, the power would come from the board. It would travel through the resistor into the anode and then out the cathode. This is just my brain and the way I do it. Now, again, these can be hooked up either way, anode, cathode. Do it both ways and you'll see. And nothing happens, but at the end of the day, as long as you do have a resistor on your LEDs, because what will happen is they don't have much resistance, if at all. And so they burn out almost immediately. They'll burn really bright and then they're done. So you definitely need some kind of resistor. Again, 470 is pretty much good for just about anything. These are 220. I found that I got a nice brightness coming from the LEDs. So everything is hooked up except, remember, I unhooked our board from our breadboard, board from the board. So I'm gonna hook the ground from our Arduino board right here into ground of the breadboard. And then I'm going to hook power that I unhooked back into power for the board. And there we go. And I think I do have a stuck pin right in there, and that's why I couldn't use that first hole. It broke off. All right, so theoretically, this should all be done, and it's, you know, looking pretty good. I'm gonna bring it back into view, and let's work on the code part of all of this. And I'm just doing one more final check that everything looks good. And once we are done our code, we're just gonna plug our USB into the computer and then transfer the code via this cord into the Arduino and fire it up. See if this thing even senses anything, or, you know, maybe we'll use the other sensor. We'll see. So let's go to the computer and I'll meet you guys there. So I'll be right there in a sec. All right, so here you guys are, and I'm looking at the computer here, and we're gonna be looking at this screen right here. Now kind of put my mouse, there it is, crazy mouse, and kind of decipher what some of this code is. Now, if you've never done Arduino code, that's fine. We're gonna go through and just kind of talk about the general principles of this code. Some of you guys are like super advanced, and you might see a couple things that are like, wow, you can really simplify this a little bit. You're being far too difficult, way too many lines. So this is kind of something I pre-wrote looking at the board before the stream and figuring, I think I know where I'm going to put these pins or insert all of our components. So we're just going to double check with the board. I'm going to bring it over right here. Here's our board. So to begin, we look at the very top of the code here, and you'll see int green LED. That's an integer. And we're basically telling the board that we have a green LED plugged into pin number 10. So I'm gonna check that right now. We have our green LED plugged into pin number 10. That's correct. And again, you can plug it anywhere and just change these numbers. You know, I just figured I was going to go from 13 on down with my LEDs, so I kind of just wrote this from what I thought I was going to do. And then I change it here, and Amicus is, I'm just making sure he's not going after my electronics, and then my LEDs disappear. All right, so int, again, it stands for integer, blue LED. We have our blue LED hooked up to pin number 11. I will check that. And yes, we do. Our yellow LED is hooked up into digital pin number 12. Yes. And our red LED is hooked up into pin number 13. Yes. So finally, our sensor is hooked up into analog 5, the A5 slot, which is this little guy right here, which we do, our orange Halloween wire. So that tells the code when it runs, this is where stuff is hooked up. Now, under void setup, this is the section where the program will just read, the Arduino will read one time, just to kind of set it up and tell it, like, give it the lay of the land. So in continuing to get it the lay of the land, pin mode, green light. So we want to set the pin mode to an output. Now remember, all the pins by default are input. Well, we want to send volts to the LED so it lights up, right? So we want to set that up as an output. For the blue LED, well, same thing. We want that to be an output. The yellow LED output, red LED output right here. And then for pin mode, for the sensor, now this is where it's different. We want it to be an input. Now, because everything is set to input by default, that line doesn't even have to be there, but I like to catalog everything that's plugged in, so that way it's easier to check, and you know, you can find any type of mistakes or maybe something that you forgot to do, or maybe heck, you forgot to plug in the sensor, you know, and then you see sensor, oh, it's not in there, okay, let me plug it back in. So it's really helpful to catalog everything, at least it is for me. As you code and you progress, you might find your own you know, ways to do it. So let's see. So we got the sensor input. Serial begin 9600. Without getting like into too much details, it's basically going to gather the sensor info, so that way later I can print it on a screen. You know, I can actually see number readouts, you know, because obviously you can't see any numbers on here, you know, so it'd be nice to see what ranges we're getting, just so I can calibrate these LEDs better. And we'll get to that. So that's kind of, for now, all we need to know about serial begin. And of course, in the comments, if you guys are interested in learning more about Arduino and I'm learning along as I go, we can do fundamental Arduino classes, do some really fun projects that are easy, code together, and learn all this stuff so we can all build better and more badass projects. Yes, I said it because that's the theme of this entire stream. All right, so looking, okay, so now we're at the void loop. This is the part of the code that gets repeated over and over and over again, endlessly, until you unplug your Arduino or it runs out of power. So basically here we're saying that we're using the analog to read the sensor. Without getting into huge, you know, details, you basically have to name everything. So sensor reading, analog read, sensor, and this will make more sense going going forward. Serial print line. Now remember we have serial begin here. Serial print line just says, hey, can you print this number in our serial port right here? This little, or serial monitor. When I click this, a blank screen will come up and numbers will begin to show up, giving us the analog values of our sensor. I'm not going to do that now because obviously this isn't hooked in and it's going to like be angry at me if I do that. We'll just get an error. I'm being dramatic. All right, so we're gonna start our loop here, and so it's we did a couple things here, and then digital write, green LED low. This is kind of saying how everything should start off. We want all the LED lights off when we start. So blue, yellow, red, low means it's getting 0 volts, high means it's getting 5 volts. Everything is starting off. And then if the sensor reading is less or equal to 255, now remember, analog goes from 0 to 1023 or 1024. I gotta look that up. But I believe that's what it was. And I believe it's 1023. And so what I thought, like in my head, was to give each of these a quarter, you know, like take that range and chop it into 4 and then give them each, you know, their range. Now there is kind of a flaw with that, because what if the human can't even produce the red level fart? I mean, what if they just can't do that nuclear? Maybe humans can only go up to the blue, but I figured I'd set that up for now. That way I have some ranges and let this run and see what regular air is like, and then start testing it. I have to find more test subjects and start testing these and see how high we can get these numbers and what the average number is, and then I can set all these ranges lower, which is what I think I'm gonna have to do. But anyways, to evenly divide the range, we want to set it so the first quarter is from 0 to 255, and if it senses that, that's going to be called my general range when nothing is going on. Well, then you want to write the green LED high, which means send 5 volts to it and keep it on for a second, and then write low, which means 0, which turns it off. So what are we doing here? We're blinking the LED. We're turning the green on and off to say, hey, everything's okay because the value is below 255. Now, people who have worked with sensors might already be looking at this and like, her ranges are completely whack. But that's for me to find out in the future tests. We might find that the highest fart that someone can produce is a 255, upon which then all these values are going to be transferred lower. This is just a starting point. So that's, you know, if the we're in the green. Now, if the reader, if we get a reading of 255 to 511, in essence, greater to or equal or less than 511, then the blue LED is going to light up for a second, and then it's going to go off. You know, and so in essence, again, we're blinking the blue. The blue one is going to start to blink like, something's going on here. This is your preliminary warning to run. And then if the reading is between 510 to less than, or, you know, 765 in essence, then do the same with the yellow. Blink the yellow. And if none of these apply, well, that means that the reading is higher than all of these ranges. This is the last quarter of the range. Turn the red on. Just turn the red. Hurry up. So the red will blink, be on for a second there, and then it'll be off. So again, the red will start blinking. So if none of these cases are met, well, then we know that it's high, you know, so go ahead and blink the red and then read it every second, you know, and it'll go through the loop again. Once it reaches here, it starts all the way at the beginning up here and goes through the whole thing every second. So I've checked that everything is plugged in correctly. So let's plug it in. And I usually do all of my coding and uploads on the laptop, hence why you saw the laptop there. So let's plug this in, give it some power, and see what happens. You can see the little fartometer here, name for it. You know, of course, I elevated, call it the flatulosity meter. It's far more chic, if you will. So meet me back at the workbench and I'll be right there. All right. Okay, so moment of truth. Let's see if this actually works. Let me fire this up. And the fan on this is pretty loud, so I'm gonna speak over it because I know the mic will probably catch it. So let me get in here. Wakey, wakey. All right. There we go. So I have the code on this computer is the exact same code that was on the other computer. And now according to the data sheet, and all these sensors and all your components come with data sheets, it's important to read them because they tell you what's the best temperature to operate in and what temperatures or humidities that you just don't really get accurate readings. So you want to pay attention to that. Obviously, this is sensitive to a variety of gases, but sometimes it's more sensitive to one gas versus the other. So you want to know all that, and for this sensor, it senses all the gases that it does at the same time. So it's not like you can get a reading that says it senses this much CO2 and it senses this much hydrogen and all that. It's just kind of a bulk number. And what you can do is calibrate it to the gas you're trying to measure. For our purposes, I just want to measure the total volume of bad gas and use that rather than getting into any specifics. You can also, in the program, have the analog value, which is kind of meaningless to us, be converted into like parts per million if you're doing a science project, or a lot of people use these sensors to monitor the air quality in their home, which is important. And you might want to know the actual, ppm of the gases. So there's a calculation or a conversion that you can write into your code or use a library that'll give you that. I'm just plugging the Arduino in. All right. So here you can see, and I'll give you a better view of what's going on. And here it comes. So you can see that the Arduino is powered on and it's already blinking in the yellow. And I'm going to check that on the serial monitor, which is on this computer here, but I'll read out the values to you guys. 562, 523, 491, it's falling. The values are falling. According to the data sheet, the most important thing you have to do with this sensor is give it its burn-in time, and it's different for different sensors. For both of these sensors, you need to allow it to have a burn-in time of 24 to 48 hours. Now, burn-in simply means it's fancy for plug it in for that amount of time, because there's a sensor in here that needs to heat up and warm up for that amount of time before it gives you accurate readings. And that's why the lights are kind of like all over the place. But I can already start checking my code in that if I'm getting a value of 340, I can see that we're within range of the blue LED. So I can already say with a decent degree of confidence here that my ranges are going to have to be adjusted. It could be that I find that no one will ever hit the red, and then that just kind of makes the project boring. So by using both numerical values and nose values, we'll calibrate this through the code, meaning giving it realistic ranges. Maybe we'll have to set the green one to 0 to 10, and then 10 to 20, and 20 to 30, something that makes a little bit more sense. And maybe this will only ever reach 500 versus like 1,000. So we'll do that after a couple days. So I think what I'm going to do is allow the sensor to burn for 2 days, and then I'm going to swap it, and just like to be ready in case I want to switch, burn in the methane sensor as well, and then we'll be ready to test one, test the other one, and see what happens. Kind of trim our numbers, get the ranges right. These arbitrary ranges were good in just kind of seeing, heck, does this thing even work? So we'll see. I'm going to be back where a lot of testing will be done. Got a lot of very specific cooking to do to be able to test this. Also, volunteers. We'll see if we have any volunteers. I know Eeyore, my dog, will certainly volunteer. He is king of the SBDs. Oh my gosh, it's very embarrassing when you have guests over. But you have been known to, frighten us and melt our skin off too, right, Amicus? So thank you guys for joining me. We have prototyped our FART-O-meter, or as I call it, let's just upscale this a little bit and call it the flatuosity meter, right? Very, very fancy, right, Amicus? So next time I'm going to return, and I'd love to gather your ideas on how to package this. I mean, this is great, but this is not really something that you can run around and put near someone's butt and say, hey, go in here, you know? It makes it really tough. So I was thinking between a couple different options, and one option is very simply, the simplest one is to screw this down to not a 2x4, but like a 1x3, and just kind of like extend it near the person. But that's kind of like crude for a flatuosity meter. We need to make it like more upscale. So the other idea was to hide it into something familiar. It could be a briefcase, you know, everybody knows those 2 p.m. lunches. Whew, in those conference rooms, it can be tough, you know. So maybe we can hide it into something that is in disguise, and you can just set a briefcase next to someone or under the table, and it can start detecting. We can even hook up a buzzer for when it gets into the red. You know, at this point, you don't want to be in disguise or discreet about it. You want to warn everybody in the room. And then the other idea is to just maybe make a cool, like, Ghostbusters-like PKE meter, if you remember the one that Egon had, where maybe we can have the sensor, so we don't have to get so close to the subject. Maybe it can extend via a servo, and then that way you can, you know, test your subject, and then the reading will come back to a certain cool looking sci-fi device. So those are the 3 scenarios that I'm thinking of, and we can also do a combination thereof. So post your comments and your suggestions below of what your idea is for packaging this, and of course we can continue the discussion on Discord, via Patreon, and also on YouTube, the various places you can join. And thank you guys so much for joining me today. Again, I am Rachel DeBarros, because it's through your Wrench Army direct support that we're able to do this amazing humanitarian level project. Bye!